Deimos is the smaller and outermost of the two moons of Mars, the other being Phobos. It was discovered by Asaph Hall on August 12, 1877, just 6 days before the discovery of Phobos. Here's everything known about Deimos. Deimos is small, irregularly shaped, and resembles an asteroid. Its dimensions are approximately 15 by 12.2 by 11 kilometers, 9.3 by 7.6 by 6.8 miles, making it one of the smallest moons in the solar system. The moon has a very low mass of 1.48 times 10 superscript 1 kg. The total surface area of Deimos is about 500 square kilometers. Deimos has a low average density of about 1.471 g/cm superscript 3, suggesting it is made primarily of rocky material with a possible high porosity, implying that it could have a rubble pile structure. Deimos has a weak gravitational field due to its small size. The surface gravity is about 0.003 meters per square second, or approximately January 2500 that of Earth's gravity. A person standing on Deimos could easily escape its gravity with a simple jump. Deimos orbits Mars at an average distance of about 23,460 kilometers, 14,580 miles, making it much farther from Mars than Phobos, which is just 6,000 kilometers away. Deimos takes 30.3 hours to complete one orbit around Mars. This is slightly longer than a Martian day, known as a sol, which is about 24.6 hours. Like many moons in the solar system, Deimos is tidally locked to Mars, meaning the same side of the moon always faces the planet as it orbits. Deimos has a very circular orbit, eccentricity 0.00033, and orbits almost exactly in Mars' equatorial plane, with an inclination of just 1.8 degrees. Deimos has a dark, smooth, and dusty surface. It reflects only about 7% of the sunlight that hits it, meaning it is very dark. Its reddish color is similar to that of other asteroid-like bodies and is thought to be caused by space weathering and a high content of carbonaceous material. The surface of Deimos is less cratered compared to Phobos, suggesting it has been smoothed out by a thick layer of fine regolith, dust, and small particles. Swift, after Jonathan Swift, the author who predicted the existence of Martian moons. Voltaire, named after the philosopher and writer who also predicted Mars moons. The relatively smooth appearance of Deimos is likely due to a large amount of regolith, which may cover older craters. Deimos is covered in a thick layer of regolith, possibly meters deep. The regolith is formed by the impact of meteorites over billions of years, breaking down the surface into fine particles. Deimos composition is similar to that of C-type, carbonaceous, asteroids, which are composed primarily of silicate rock mixed with organic compounds and water ice. Its dark, carbon-rich surface suggests that it could be a captured asteroid from the asteroid belt, but this theory is still debated. The origin of Deimos and Phobos is still debated. One theory suggests that Deimos may be a captured asteroid from the main asteroid belt between Mars and Jupiter. This is supported by its irregular shape and composition, which are similar to carbonaceous asteroids. However, the almost circular and equatorial orbits of both Deimos and Phobos make this theory somewhat problematic, as capturing an asteroid into such a stable orbit would be difficult. Another theory posits that Deimos formed in situ from the debris left over from the formation of Mars. This scenario would involve material from Mars coalescing to form its moons, which could explain their orbits but doesn't easily explain their asteroid-like characteristics. Another possibility is that both moons were formed from debris thrown into orbit around Mars after a giant impact, similar to the Earth-Moon formation theory. Unlike Phobos, which is gradually spiraling inward toward Mars and will eventually crash into the planet or break apart. Deimos is slowly moving away from Mars over time due to tidal interactions. Over millions of years, Deimos' orbit is expected to gradually increase. However, because of its distance from Mars, these changes are extremely slow compared to Phobos. Deimos has been observed and studied primarily through flybys and remote observations. Mariner 9, 1971, the first spacecraft to capture close-up images of Deimos. It provided the first detailed views of its surface. Viking 1 and 2, 1970s, these missions provided additional close-up images of Deimos, mapping much of its surface. Phobos 2, 1989, a Soviet mission that imaged Deimos as well. In the 2000s, more detailed imaging has been conducted by Mars orbiters like Mars Global Surveyor and Mars Reconnaissance Orbiter, further refining our understanding of Deimos' surface and orbit. While no mission specifically targeting Deimos has been launched, future missions may aim to explore both Phobos and Deimos, as studying these moons could provide insights into the history of Mars and the solar system. There have been proposals for landers, orbiters, and sample return missions to these moons. Because of its low gravity, proximity to Mars, and possibly stable resources, Deimos, like Phobos, has been considered as a potential staging point for future human missions to Mars. A manned mission to Deimos might be less risky and expensive than landing directly on Mars. Studying Deimos can offer clues about the early history of the solar system, including the formation of moons and planets, and the processes that shape small, airless bodies. Deimos, like Phobos, has been associated with the gods of war in various mythologies. It is named after Deimos, the personification of terror or dread in Greek mythology, who, along with his brother Phobos, fear, accompanied their father, Ares, Mars, into battle. This naming convention ties Deimos and Phobos directly to Mars, the Roman god of war. In literature and popular culture, Deimos, along with Phobos, has often been referenced in science fiction stories, games, and movies about Mars exploration or Martian colonies. Its eerie, desolate landscape makes it an evocative setting for futuristic exploration narratives. Deimos is smaller than Phobos. Deimos is farther from Mars and has a longer orbital period. Deimos has fewer large craters and a thicker layer of regolith, giving it a smoother appearance than Phobos. Despite being relatively small and less studied than larger moons in the solar system, Deimos remains an intriguing target for planetary scientists, especially due to the potential it holds in revealing more about Mars' history and the processes that shaped the Martian system.